We are now doing problems on Newton's law of motion. The first problem is the force acts for 20 seconds on a body of mass 10 kg, after which the force stops and the body describes the 50 meters in the next 10 seconds. Find the force. I have to find the force. Now, a long playing record revolves with a speed of 33.5 revolutions per minute and has a radius of 15 centimeter. Two coins are placed at 4 centimeter and 14 centimeter away from the center of the record. If the coefficient of friction between the coins and the record is 0.15, which of the two coins will revolve with the record? Take G as 9.8 meter per second. The next is a car of mass 1500 kg is moving with a speed of 12.5 meter per second on a circular path of radius 20 meter on a level road. What should be the frictional force between the car and the road so that the car does not slip? What should be the value of the coefficient of friction to attain the force? This is the third question. Three blocks are connected together and are pulled by a force of 50 Newton on a horizontal table having friction. The coefficient of friction is mu. Find the tension and acceleration. A machine gun fires a bullet of mass 40 grams with a speed of 1200 meters per second, and the person holding the gun can exert maximum force of 144 Newton on it. What is the number of bullets that can be fired from the gun per second? Next is an interesting question. This has come in the IPU examination also in external. Sometime I remember. A monkey of mass 40 kg climbs on a rope which can stand a maximum tension of 600 Newton. In which of the following cases will the rope break? The monkey climbs with an acceleration of 6 meters per second square. Monkey climbs down with an acceleration of 4 meters per second square. The monkey climbs up with a uniform speed of 5 meters per second square and falls down the rope nearly under gravity. Take G to be 10 meter per second square. Now, students, you will not copy the answer straight away. You will stop the video and then you will try to do this question on your own. These questions on your own, and then you will, if you aren't able to do it, then you will see the solution. So I'll start with the last one, the solution for the sixth one. So I hope you people know the lift problem I did with you guys quite in some past video. That is, if the lift goes up with an acceleration and the lift goes down with an acceleration. Here, see, what is the problem? The monkey is on the rope. The monkey is here on the rope, right? There is a weight on the monkey and there is a tension now. Instead of reaction, there will be now tension. In there, it was just what? It was just reaction because he was standing on the floor. That is the same lift problem. Remember that. So what is the free body diagram? And it is going up with an acceleration of A. A is equal to 6 meters per second square. So now T is equal to, so you write down the Newton's equation. Wait, uh, the procedure to do is this: T minus mg is equal to ma. Now T is equal to mg plus A. This is solution 6. Solution 6. This is solution 6 plus ma, and this is equal to mg plus A. And C, what is this question saying? The question is saying the monkey is climbing with has the mass 40 kg. So the mass is given to be 40 kg. Write down 40 kg. Now acceleration they have asked to take 10, and this is plus 6 meter per second square. This comes out to be around 4 and 16. That is newtons, and 16 of 16 and 40. This is 40. Sorry, not 4. By mistake, I wrote it 4. Sorry, it is 40. It is 40. It is 40 into 16. Now Newton it will be. This kg meter per second square is always Newton. Now this is 16,640 newtons. And can you see the maximum that it can take is 600 newtons. So the rope will break. Rope will break. Wait, rope will break. Rope will break because the rope will break as the rope can withstand only 600 newtons. 600 newtons, and this is more. So the first part is over. The monkey climbs down. Again, you draw the free body diagram as I told. Now this time you have this time the mg is always in this side, the tension is always in this side. Now the acceleration is in this side. Now it is coming down with an acceleration. So t mg minus t is equal to MAC. If you know the free body diagram and you can write the equations correctly, there is no chance that you will make mistake while doing this type of problem. Mg minus Ma, and M is here, G minus A. Now you have M as 40 kg and you have this 10 meter per second, and how much is it? 5 meter per second square. So 4 meter per second square, not 5, sorry, but it's 4. It's 4. It's 4. It's 4. So now it is nothing but 40 into 6 newtons. This is 240 newtons. The rope won't break because the rope can take 600 newtons. Now let us see the third case. What is the third case? The third case was the monkey comes down with a uniform speed. If it is coming with a uniform speed, then uniform speed, the third case uniform speed, the third case it is. Uniform speed of velocity is given to be 5 meter per second. Therefore, acceleration is 0, and in this case t equal to mg, that is nothing but 40 kg into 10 meter per second square, the gravity, and this will give me 400 newtons. The rope won't break. Now the last part of this story is the monkey is now falling down. Now this is mg, this is t. Now he's coming down with acceleration equal to gravity, basically in this direction. So you will use this equation. So this equation will be t is equal to mg minus ma, and here a equal to g. Therefore, this will be mg minus ma, and this will be 0 newtons. So with this, we did this problem. Now we will do the other problem. I'll go, let's see which problem it is. Let me just a minute. I hope you've understood this problem, how to deal with this. I did the first case, I did the second case, I did the third case, I did the fourth case. These are all the 4 cases together. Okay, fine, let me write down. First case, second case, right? Then this is the third case. I hope you understand. And this is the last one. This is the fourth case, the diagram for which. Now with this, we'll come down to the second problem. A machine gun fires a bullet of mass 400 grams with a speed of 1200 meters per second. The person holding the gun can exert a maximum force of 1400 newtons on it. So, what is the change? What is the number of bullets that can be fired per second? How many bullets can be fired per second? This they are asking. So, see, there are no external forces. Very simple. There is only internal forces. Therefore, there will be change in momentum. What will be the change in momentum of the see? Let us assume question number. This is, I think, question number 5. Solution 5. This is solution 5. Now let the number of bullets be. Let the number of bullets be number of bullets fired per second. Number of bullets. They're asking this. Bullets fired. Bullets fired per second. Per second. Per second is say n. So you see one thing. What is that? See, the person holding the gun can exert a maximum force of uh, 144 newtons. See, I told you one thing. Look here. I told you about impulse. I hope you remember that formula. That was F average delta T in is equal to delta P. I hope you to remember this derivation. I'm not doing with vectors right now because I need to just solve this problem. Now, force is, this fellow has a force of say, uh, this fellow is giving me a force of 144 newtons. This fellow is giving me a force of 144 Newton, right? And the change in momentum, see, initially the bullets were at rest. So now, what is the momentum? mv in minus in 0 because initially they were at rest. Now they are moving. And how many of them? N. And what is the time that this fellow, what is the number of bullets that can be fired per second? Per second they are asking, right? So let us take it as 1 second. Now see, 144 newtons is equal to n for 40 grams, that is 40 by 1000 kg into velocity, that is 1200 meter per second. Now Newton means, this Newton means, let's write down, Newton means kg meter per second square, and this is n into 40 by 1000 kg 1200. This is meter per second. See, 1 kg, this meter goes out. Now they are asking how many bullets. This is bullets per second. Remember, this is per second. So what I'll doing is that I'll cancel this with this. This 1000 will cancel with this. Now you are left with 12. 12s are 144 and 4 3s are 12. So you have got only n is equal to 3 bullets per second. This is the answer. I hope you've understood what I wanted to tell. See, the point is, let's read the question again, and let us understand. See what the question is saying. The question is saying a machine gun fires a bullet of mass 14 with a speed of 1200 meters per second. This is the velocity. Initially, it was at rest. The person holding the gun can exert a maximum force of 100 Newton on it. Right? What is the number of bullets that can be fired from the gun per second? Per second. So that's why you see, I know the formula for impulse. The complete formula for impulse is this. The number of bullets fired per second is n. This is the formula. This is F average. Wait, I wrote something else. Wait. Let me write F average. I have already discussed this formula with you. F average is delta T is delta P. Now it is for per second. So I've taken this as 1. N is the number of bullets per second. Per second cancels out here. Now see, per second here and per second here, because n is per second. Remember, number of bullets per second. This n is actually number of bullets per second, and this is 1 second. This 1 second and 1 second cancels out. Mass is here like this. This is in kgs. Wait, let me write the kg here. This kg cancels. Meter and this second remains here. Number of bullets per second. That's why I hope you got the point. Let us see the next question. What is the next question? The next question is, 3 blocks are connected by a together by a and pulled by a force of 500 Newton. The coefficient to find the tension and the acceleration. Very simple. I'll not do it full. You will do the. I'll just explain you how to do this. See, you have one situation. This is the surface. One mass is m1. The other mass is m2. Oh, and I think the other mass is m3. Right? This is the way they are connected, and the force is pulling them. There is a friction everywhere. Here there is a friction, here there is a friction. This is m1, this is m2. Sorry, m2. Well, let me rewrite it again. Let me rewrite. This is m2, and this is solution number 5. I hope so. Solution 5. Now you see what happens. Break each body. First one, I'm taking the free body diagram of the first one. See, m1. This is F. There is a tension, say T. There is m1g. There is a normal, let's call it n, and there is a friction in this direction, 1. Now for the second body, m2, I'm talking about the m2 body. There is only tension. The action is this, the reaction is this, right? There is m2g, there is a normal, right? And there is tension. Now see, the same tension, whatever tension you see here and here, that this same tension won't be here. This will be T1 and T1. There will be some different tension now. Let's call it T1. And there is a friction, of course, in this direction. You got this? You will see another equation for the last one. For the last one, you have only this M3G. This is M3. M3G here. There is nothing normal. Let us call it normal N1, N2, and N3, just for the sake of not confusing the things. And there is a tension here and there is a friction here. They all are going in the same direction. So I can say x1 equal to x2 equal to x3. Therefore, A1 equal to double differentiate. Double differentiating the constraint equation. The equation. Constraint equation, right? So I will get x1 double differentiate with double differentiate. Let me rewrite it properly. Wait, it is looking a bit odd. Wait. This is the constraint equation. Constraint equation. Let's equation, right? This is the constraint equation. What? X1 equal to x2 equal to x3 because they are all moving in the same space. Now what I do is that double differentiate them. Double differentiate, double differentiate, double differentiate. This is t with respect to time I am doing. So what I get is from here I get a1 equal to a2 equal to a3 equal to a. They are all in this a direction. This also is in this direction, and I know how you should write. I'm not going to solve this for you for sure. This is for the first body, m1 body. I'm writing down the equation. Solve it on your own. Solve it on your own. And if you don't do mistakes, things will be fine. See, for the first one, it will be f m1 body. I'm talking about the m1 body. F minus t minus f equal to m1a, and you should know f is mu m1g. As always, I've told you, substitute this here. The first equation will be this. See, I'm writing down the first equation for you here. F minus t minus mu m1g is equal to m1a. Now this is the first equation, equation number 1. Now let us see the second one. Second one means this one. I'm talking about this one. Now see, you will have t minus t1. Yes, you will have second one m2. I'm writing t minus t1 minus f is equal to m2a. That should be the thing. Let me check. Yes, t in this direction, t1 in the opposite direction, f in the opposite direction, and in okay. Here also f would be equal to mu m2g. So your equation comes out to be t minus t1 minus mu m2g is equal to m2a. This is equation number 2. Now that for the third equation, now you can see very clearly, it's so simple that you only have, sorry, this is t1 because this end is t1. So this end has to be t1. Now you have, now let's see the last equation. T minus f is equal to t1 minus f is equal to m3a. So let's write down t1 minus, so f is what? Mu m3g. T minus f, that is mu, sorry, wait a minute, let me rub it out. Let me write it again. Mu m3g is equal to m3a. Now what you have to do is just add all the three equations directly. I was not supposed to solve this, but still doing it. If you add this three equation, let me add it here. See, this tension will cancel out. This will cancel out with this. What will you be left with? F minus mu g all m1 plus m2 plus m3, and then you have your, this is equal to total of this m1 plus m2 plus m3, and this is your a. So now your acceleration comes out to be f minus mu g m1 plus m2 plus m3 and upon m1 plus m2 plus m3. And after this acceleration is done, you can put in this equation to find t. In this, after t is found, you put the value of t here, then find t1, then put or you can find t1 directly from this equation. See, t1 you can find directly. T1 is nothing but mu m3g plus m3a. Just put this value here. Then you will be able to find it out. But do it very carefully. Take the LCM very carefully. That's the point. I'm not doing the next of all. See, T1 is found. Now you can find T also from here. Let me do it for you. Let me tell you what to do. See, take the second equation. Take this equation I'm talking about. Now, all this T1, mu2, m2g all will go on that side. See, you have T minus T1 This T1 will go T1 will go there, plus mu M2G plus M2A. T1 you will get from here, put this value here, and A you already have found, put this value here. You will get your answer for T. You needed this tension. I asked for two tensions. I wrote the question was for tensions. If you see the question, there was only one word, acceleration. I didn't write accelerations. I wrote tensions. You see this question. See, I asked find the tensions. I hope you're seeing this tensions. And I didn't ask tension. And I didn't ask acceleration. I didn't ask accelerations. I asked acceleration only. I hope now you understood this question. I think it was question number 6 is done. Then 5 is done. Then this was 4. Sorry. 5 and this was 4. Sorry, this was 4. This was 4. Just a minute. This was 4. Now let me see which is the third one. Which is the third one? Which is the third one? Which is the third one? This is a good question. A car is moving with a speed of per second on a circular path, right? And what should be the frictional force? Uh, what should be the frictional force between the car and the road so that it's not slipping means you are talking, the word slipping comes as soon as the word slipping comes in your mind. You should keep one thing in your mind. You are asking about those banking and all that, banking of road and all that stuff, VMAX and all that stuff. They are asking nothing more than that. They are asking. Got the point or not? Clear that what they are asking, and you need to understand that part only. So they are saying this body is moving, a car is moving with the speed of this. See what was given to you, write it down. Let's write it down. Mass is given, speed is given. I think 5 is done, 4 is done. I think I'm doing the third one. I'm doing the third one. Let me check. Yeah, I'm doing the third one. Third one, let's do the third one. This is the third one. Now you are getting some idea. Now see the third one. Let me draw this, and this is the third one. Solution third. Do not see the solutions and do it. Stop the video and do it. See, mass is given to you 1500 kg. Your velocity is given as 12.5 meter per second. And the radius of the road is given, I think so. Let me check whether they have given the radius or not. Let me see. Just a minute. Just a minute. Let me see whether they have given the radius or not. Just let me check. Yes, the radius of 20 meter they have given. Fine. Now they have given me all this data. So now let's do the business. Now we have got the radius. We have got the radius also of 20 meters. Now the frictional, see, I told you centripetal forces are always going to come from friction or from gravitation or from tension or your whatever. They are pseudo forces. The frictional force must equate, see, sorry, let me write this way. Wait, let me write this way. This way. The frictional force must balance your centripetal force. So what is your frictional force? What is your frictional force for anybody? You know it is mu mg. And this is mv square by r. You know that derivation. Cut this all m's. What you are left with? Uh, wait. Wait a minute. What am I doing? Wait. Just a minute. I think they are asking me what? They were asking me, it's so up and down. Wait, they're asking me what should be the frictional force. So how can I do this? This cannot be done. I'm trying to equate. They have given me the velocity. Wait, they have given me the velocity. They have given me the radius. They have given me the mass. How can I write this? It's not possible for me to write this. They're asking frictional force. So this is wrong. Sorry. This has to be, this is correct because the friction force, the centripetal force comes from frictional force due to, because this is a, this is a pseudo force. The frictional force, this centripetal force is a pseudo force. It is due to some other force. So they are asking mv square by r. Just do this. Let's write 1500. Then I'll write the unit at the end, no problem. 12.5 into 12.5 by 20. So let's do the calculation. You can use a calculator. I'm using a calculator and it is 1500, 12.5 by 20. You're allowed to use scientific calculator in GGSIPU University. No problem. 1.172 into 10 to the power of 4 newtons. Because the force, it is newtons. Now frictional force I have found. I have found out the frictional force. This is 1.1, sorry, 1.1. 1.1. Wait, it's looking very odd. Wait, let me do it again. It is 1.172 into 10 to the power of 4 newtons, because force it is, whatever force, it may be frictional, whatever, it has to be Newton. Now what they are asking, let me check. What they are asking, just a minute. Let me take this side, scroll up this way. They are asking me frictional force I have found. What should be the value of the coefficient of friction? Now I will have to do this. Actually, that was in my mind, coefficient of friction. That's why I wrote earlier mu mg here. So now your mu mg is equal to this quantity. So what you do is that, very simple. M, you have your this as m v square by r. Now just cancel the m. You have mu equal to v square, what is 12.5 into 12.5, and then you have your, this is meter per second, remember, meter per second, meter per second. There are 2 meter per second here, for one for this and one for this. Don't mess up with the units. And then you have your G in the down. G is what? You are taking it as 9.8. You can take meter per second square, and one more meter is there. You can see. G is there. This is V square by R. V square by R, and G has come, and what you need is more. R is 20 meters. See. This second square and this second square cancels out. Meter and meter cancels out, because mu is unitless. Mu is unitless. Be very careful about your units. Don't mess up with your units. Let me do it again. Wait, see what I'm doing. Let me rewrite this whole thing so that you don't mess up with your units. Let me do this thing very clearly again. See, this is 12.5 meter per second. This is meter per second square. And let me write the unit for these two. Meter per second into meter per second. 1 second cancels out with that power. 1 second cancels out with this downward. This is also meter. Cancel this meter with this meter. Cancel this meter with this meter. So this is completely there is no unit for this. There is no unit for this. So what you write is that after doing the calculation, you will get 0.8. That's all. No meter, no miss, because coefficient of friction is between. And remember, it has to be in between 0 and 1. Otherwise, you are wrong. Now we have a question. The second question as I was going through. Wait a minute. Yes. The second question. Third has been done. The second question. This is a long playing record. Revolves. I'll show you. See, revolutions per minute has a radius. I read this question. You read it carefully. I'll make you understand. Now, this is a very quite a good question, and let me now tell you what to do with this question. First of all, see, mu is told to you. This, the frequency has been told to you in an RPM. Convert it into, whenever you see RPM, convert it into RPS, that is revolutions per second, by dividing it by 60. This is an improper fraction. Convert it into a proper fraction. Now, this is, see, you write meter per second for linear velocity, this one. You write meter per second for linear velocity, but you cannot write for, when there is a frequency revolution, you cannot write linear velocity. You have to write angular velocity. This is called angular velocity. Let me write it down. Wait a minute. Let me write it down. This is called angular velocity. Angular velocity. Something very important concept. That is 2 pi nu. Always, this is the formula. You write it down. R is given to you, mu is given to you. They are saying, the question is, suppose this is the disk moving. There is one coin here. Let me write the other coin with some other color. Wait. The other coin is somewhere here. They are saying, in this, when the disk is revolving, which of the coin will stay and which of the coin will fall out, will go out. This one will go out or this one will go out. We don't know. So let's see. See, in order to, you remember that question I did on banking, that if the car has to stay on the road, then the friction should be more than centripetal acceleration. Frictional force must be more than, in order to stay, I told there also. Let me rub these lines, unnecessary lines. Wait. In order to stay, the frictional force F maximum should be greater than your angular centripetal acceleration, centripetal FC. This is the way I write. So now what you do is that in the car motion also you saw it. So we have F max. You know you mu mg. There is nothing more than that in this mu mg. Now this should be greater than, this should be greater than. Now see what happens. What is your force? mv square by r. Can I use this expression? Is there anywhere can I see v? Can I see v anywhere in this? Can you see whatever I have collected data? Wait a minute. Whatever data I have collected, I just told you linear velocity is meter per second. Is it expressed in meter per second? But there is no value for this. But there is a value for omega. This omega will play the role for me because I know mv square, this thing I have shown you in my earlier video, can be written as m because v is equal to r omega. You can write this is r omega square. This is the thing. This is the thing, m r omega square. Now if, now see, now this thing is can be written as mu mg is greater than equal to m r omega square. Instead of this equation, now you use this equation because omega is here. Now they are saying which of the coins will, see, this has to be more than this, undoubtedly. This mass and this mass goes off. Mu is how much? Mu is 0.5. Gravity, they are asking you to take 9.8 meter. You need to use a calculator, let me tell you, by the way, very clearly. And let me do the calculation. I don't think so I did the calculation here. Yes, let me find omega. Wait a minute, let me find omega for you. Omega is how much? Omega is 2 into 22 by 7 into 100 by 3 into 1 by 60. 1 by 60, right? Now let's see what happens. This 2 will go with 30, right? This, let the 2 go with 30. This 0, let the 3 go with this. Now you see you have 220. This is 220 on the top. Now 9 7 is 63. This is rads per second omega. So you have your g greater than r omega square. You write 220 by 63. Now you need a calculator. If you do not have a calculator, buy it and do it because you're allowed to use calculator. Now this is going to be around 0.5 into 9.8 upon 220 up by 63 whole square. And this r should be less than this quantity. That is, this comes out to be, this is, see, one thing, this is in rad per second. This was this is now in meter per second. So R comes out to be less than 0.12 meter. That means this is less than 12 centimeter. The coin which is less than 12 centimeter will rotate with the, that is, the coin that shall, that has radius, has, that is placed, wait a minute, let me write down properly. That is placed at a of distance of 4 meter from 4 centimeter, 12 centimeter it is, yes, 4 centimeter. Just a minute, let me not rewrite things, overwrite things. Wait, this is 12 centimeter. This is the thing, less than 4 centimeter, less than this is distance of 4 centimeter. Coin that is placed at distance of 4 centimeter will will rotate with the disk, with the disk. The other will fall down, and the other will fall down. It was a good question. Fall down, quite a good question. Now we have the last question. I think this is the first. I'm going on the opposite direction. And this is the first question. A force acts on a body for 20 seconds of mass 10 kg, after which the force stops and the body describes 50 meters in 10 seconds. Now see what it exactly is saying. I will explain you here. See, just a minute, yes, here it is. Now the thing is, last solution of this, and with this you can, now you find yourself quite confident with the questions. Solution 1. Now see, you have a mass of 10 kg, very simple. Now you have a time of 10 seconds and you have gone a distance of 50 meters. The force acts for 20 seconds. This is the very tricky word they have used here. Now see, initially the thing was at rest. So you have V is equal to U plus, sorry, you need to find the velocity. V is equal to U plus AT, you write down this equation, no problem. You can write down this problem. Now you need this A actually, because you are asking the force means M into A. This A is asked, this A has been asked. Wait, let me rub this has been asked. Wait a minute. Now your V is equal to this, you need to find this V from this data and this data. So V is 50 by 10. So this comes out to be 5 meter per second. Put this V here, 5 meter per second. Initial is 0 meter per second, no use of writing, plus A, and this is 10 meter per second. So A comes out to be 1 by 5 meter per second square. Very simple. Now what you have got is F. F you have got. M is 10 kg and this A is 1 upon 5 meter per second square. So this comes out to be 2 newtons. Now the point is, if they had asked impulse, I'm doing it extra for you. Impulse, that means this force into this time. The force is how much? 2 newtons. 2 newtons, and into time, that is 20 seconds. That is nothing but 40 Newton seconds. That is basically impulse.